Alright, welcome. We're going to talk about, this is another geometry video. We're going to talk about section 1.4 from the text, and it's about measuring angles. So we'll talk about how to name angles, and then how to find and compare the measurements of those angles. So when we're talking about an angle is basically, like you can see an angle pictured here. We're used to what it looks like. Notice how it's actually formed by two rays. So it's two rays with the same endpoint. Here, that common endpoint they'd have is A. So this would be ray AB. This would be ray AC. And we can name it a few ways. We can name it with the little angle symbol. So we can name it angle A, like that. So the vertex after the angle symbol. And notice how that's not quite this would be a less than symbol. An angle symbol actually has like kind of flat on the bottom. So angle A, you could call it that. You could do the kind of vertex point symbol. So you could do angle BAC. Notice you always put the vertex in the center. Or in this case, since there's that little 1 in the corner, we call this angle 1 right there. So sometimes I'll put a number in the corner. The sides of an angle are just those rays. So, here we're talking about ray AB would be a side of that angle, and ray AC would be another side of that angle in this case. And we would name it the same as we would name any other ray. Always put the vertex first, and then any other point along that ray with the arrow always pointing to the right, regardless of what direction that ray physically in a diagram points. The vertex, that's just that common endpoint. I like to think of it as it's the common endpoint of the rays, or the corner of the vertex. So see how A is in the corner of this angle here? That's our vertex, and we name that the same as you would name a point. So in this case, it's just the point A, a capital A. When we're talking about the interior of an angle, that's the kind of the smaller portion. You could see this angle in two ways. You could go, say, I could rotate this, this small direction right here to get from one ray to another. Or if I wanted to, I could instead go the long way around. So you could actually go this way right here. So that short path is the interior. That long path is the exterior. You can think of it that way if you're looking at it in terms of rotation. So we're usually, if we're going to measure angles, we're always going to measure the interior. That we're going to give the smaller version. So when we're talking about angles and we want to name them, we want to have two other names for angle 1. So we could actually, I wouldn't want to call this angle M. You might think, oh, I can call it angle M. Why? Because, well, couldn't angle M not just be this angle right here? Couldn't it also be this part? Or couldn't it also be this whole thing? So I don't want to use the one letter vertex for when there's some competition. Now I could call it angle M. Sorry, not angle. I don't want to lead with the vertex. I want to smash that in the middle. I want to sandwich it. Angle JMK or angle KMJ. Just like segments and lines, you can reverse the order when you're doing the three name. Like of course, in segments and lines, it's two letters that you're reversing, but you can do the same kind of reverse thing when you're doing angles. If we're looking at KML, let's kind of track first of all. What is KML? Let's look at it. Here's K, then we go to M. Then we go to L. So like that three name notation tells you sort of a direction. If you trace it out, you can see which angle you're talking about. We could call it angle 2. We could call it angle reverse this order, LMK. We would not want to call it angle M. Again, for the same reason, because, well, angle M could be the one part, the two part, or all of them together. So if we call these angle M, the reason that there's some confusion there. So that, or you might think there's some competition between a lot of them. They might think, well, I want to be called M, and this guy wants to be called M, and this guy wants to be called M, but then the whole guy wants to be called M, so nobody can really win that. Now we can also measure angles similar to like we measure segments with a ruler postula. The protractor postula essentially says this: these rays are going to go through. If you start from the center here, any ray is going to go through some in between two numbers here. And you see there's two sets of numbers. Well, you can read it from. You could read it, I'll call this counterclockwise, or you could read it clockwise. But you notice they always go from 0 to 180. And here, this A, you could either think of as it's going through 55, or it's going through 125. Just if you're comparing two rays, make sure to be consistent. I'll show you an example. If we're measuring this angle right here. So if I want to find the measurement of angle COD, the way we do that is we subtract the difference of these rays. So see how this ray OC is at 45 on the top number, and this ray D is at, that looks like 1 140. So that's like about 147, I'd say, because this is 140. That's 145, and then it's somewhere between 145 and 150. So I'm going to say 147. So this would probably be 147 minus 45. So there, that would be about 102 degrees. All right, so we're going to talk about the different classifications of angles, different kinds of angles. If your x here, like if your measurement of your angle, say that's like maybe it's like 60 degrees or 25 degrees or 42 degrees. As long as this thing is less than 90, so if your value of x here is less than 90, we call this thing, this is going to be an acute angle. Alright, if it's exactly 90, if you have your, whatever this number here is equal to 90 exactly, and sorry, I shouldn't put the degree symbol, I only don't put it because it's already included here, but if it's exactly 90, then that's going to be called a right angle. If x is greater than 90, okay, but also we want it to be less than 180, and it'd probably be better to write it like this, so it's less than 180, but it's bigger than 90. So in between 90 and 180, we would call that thing obtuse. Now, in case you're wondering, why do I have the qualification that it has to be less than 180? Because say the angle goes all the way like round circle. So let's do another color angle here. If this goes all the way around, okay, like this, we wouldn't measure again. That would be the exterior part of this angle. Because if you're going bigger than 180, actually you're less than 180 because you'd measure this small part right here. You always measure the interior, the smallest part of the angle. And if your measurement is equal to exactly 180, it doesn't look like an angle at all. It looks like a straight line, doesn't it? Well, we sometimes also call that actually, it is a line, but you could also call it a straight angle if they're asking, like say they had a point A right here. The measurement of angle A would be 180. That means that it's straight. So when we're talking about measures, if you want to classify these, if you look at LKH, LKH, well, that's this part right here. Obviously, that's acute. Okay, so this one would be acute. What about HKN? Again, I like to just trace it. HK and then all the way to N. That's going to be, it's 180 degrees. So it's going to be straight. That's a straight angle. What about MKH? So MKH, that's M, then K, then H. So that's this whole area right here between these two rays. That one's going to be obtuse. Okay. If we want to find the measures of these, I kind of skipped over this part. But if we want to look at the measures of these angles, LKN, you could find the measurement by laying this on a protractor. LKN right here is going to be, now here I'm going to actually use the bottom row since this ray is on the 0. I'm going to use the bottom row this time. So that's going to be 145 degrees. So we write this way. The measurement of LKN is equal to 145 degrees. Now the measurement of angle JKL. So JKL is, see, here, then here, then here. So we actually want to do 90. Either 90 minus 35 if you want, if you use the top part, or you can do 145 minus 90 if you use the bottom part. Either way, you can see here that the difference should be 55 regardless of which one you use. So that's going to be 55 degrees. And then JKN, see there's J here, then K here, then N. Oh, well, that's obviously, it's right here, it's right on the 90, right on the 0, 90 minus 0. It's going to give you 90 degrees. So the measurement of angle JKN is going to equal 90 degrees. So, and this will, of course, be right there. That's obtuse. This one, again, is acute. This one right here is going to be a right angle there. All right, when we're talking about congruent angles, again, congruent, that's it's given by this symbol. These are congruent angles that have the same size. When we were talking about segments, all right, say we had a segment AB and a segment CD, and we wanted to indicate that they were the same size. Remember we put the little mark there, and that mark doesn't mean a midpoint. It means that they're like this segment's congruent to this side. Remember how we talked about in figures? Like this would be a rhombus, right? A four-sided figure with all congruent sides. If I also told you that these are right angles, it's not just a rhombus, it's now a square. Or if we want to indicate equilateral triangles, we put little marks there in the sides. Well, in an angle, we put just like a little arc sort of in the corner. And that's how you indicate congruent angles. So you would say angle A is congruent to angle B. Now, if you want to talk about equality, remember that the figures themselves are congruent, but the measurements, when we're talking about measurement, that's just some number with degrees. The measurement of angle A, measurement of angle B, those are equal. All right. Another example. Here we have angle GHJ. All right, and we're saying that's 90 degrees. So here's GHJ. If that's 90 degrees, see how it has the little 2 marks? Well, what's KLM? Well, they're congruent because they have the 2 marks. This one has 2 marks. This one has 2 marks. So that one's going to be also 90 degrees. If ABC is 49, ABC is the same as DEF or FED, so that one's also going to be 49 degrees here because they are congruent. All right, angle addition postulate, basically what it says is that just like the segment addition postulate has that, if these things are sort of like on a continuous path here, we can add them. If two angles have the same vertex, and if they have a common shared internal ray, you can add these together. So let's just call this angle 1 and angle 2. Well, if you take angle 1 plus angle 2, you would get the measure of this whole thing right here. If you wanted to write that out like this, you could do measurement of angle. I'm going to name the yellow one with the 3-letter terms, AOB, plus measurement of angle. You can call it COB or BOC. The order doesn't matter. That's going to be equal to the angle, the measurement of the angle, AOC. So if we wanted to apply the angle addition postulate, well, we're given the measurement of the, and this does bother me, your book, it won't put the degree symbol usually, so if ever I leave that off, let me know. This is 155 degrees for RQT, this whole thing here. So that means these two pieces given by these expressions add up to that, so 4x minus 20 plus 3x plus 14, that's going to be 7x minus 6, that's equal to 155. If I add 6 on both sides, you get 7x is equal to 161, and if I do some quick division here, I get that x is 23. So x is equal to 23, so you might think, oh, well, that's 23 degrees. That's right here. But that's not true. They're not asking for x. They're asking for the measurement of RQS, then of TQS. Now, one mistake you want to avoid making is that, oh, well, these are both going to be the same thing because this is half. But we're not told that this ray cuts these angles in half. So you're going to get different values for each. So 4x minus 20, well, instead of x, I'm going to put 23. So that's going to be, see, 23 times 4. And really, if you want to do some mental math, my little distributive property, this is how I do this mentally. I actually think of it as 20 plus 3 times 4, so that's 80, that's 12, so it's 92 minus 20, which is 72. Now that's the measurement of angle RQS is 72 degrees. And 3 times 23, because that's what I think x is, plus 14, this would be 69 plus 14, so this is almost 70 plus 14, that'll be 84, one less is 83. So that's the measurement of angle TQS. Now how can you check this? They're not supposed to be equal. How can you check this? Well, what should they add it to? They should add up to 155, and you can check to see that in fact they do. So you can always check your answers in math. But that's applying the angle addition postulate. What if they're a straight angle? Well, first of all, what does a straight angle mean? It means that the measure of the angle is 180 degrees. So I'll do the same thing, add these two together, because they should, see how they add up to form a line? I'm going to add these two expressions together, and it should equal to 180. So combine like terms, And then so I get 13x is equal to 182 when I add 2 on both sides. And so let's see, 13, how many times does that go into 182? Let's see, go at least 10 times. I think 14 times, because I'm guessing it'll go evenly. 4 times 3 will give me 12, and it goes at least 10. And I know it doesn't go in 20 times, so 14 is a good guess. 4 times 3 is 12, and then 4 times 1. Sorry, I did too much too quick. So I know the 13 goes into the 18 once. I could do this a lot easier. 52, and then 4 goes into, 13 goes into 52 4 times, so that works out. So x is going to be equal to 14, and if I want to calculate it each, again, I just plug 14 in place of x, because I'm not solving for x, I'm solving for the measurements of those angles. And you can just multiply those out. 11 times 14 to get, and then subtract 12 from that to get the angle on the left. And then 2 times 14, 14 times 2 is 28 plus 10, so you get 38 there. So 38 degrees for the measurement of angle CEF. That's going to be 38 degrees. Now, I could multiply this out, this 14 times 11. In fact, I will, but I'm going to do it mentally. This is just 14 times 10 plus 1. Because I don't like to do algorithmic addition, it's too much writing. 140 plus 14, so it's 154. And then I subtract 12 from that. So I get 142. And I can check that by adding 142 and 38, you get 180. So the answer checks out. And that's how we work this one. That's the end of this part of the lecture. Yeah!
The views and opinions expressed in this video are solely those of Mr. Vogel and do not necessarily reflect those of the School of Sacred Heart, Agricultural, Board of Directors, Administration, Meeting Network, Sacred Heart Schools, or anyone else. Visit our website at shhkoto.org.